Hey class, I'm just gonna hop on here and do a mini lesson and just record it because the internet was so bad today and I still want you to understand this stuff, and I feel like the internet really just made it very difficult for us to understand it. So these are the two homework questions that I definitely want you to do, 9A, B, and 15. Please submit those to Google Classroom. For this lesson, you'll be able to write the function, and you're going to be talking about horizontal and vertical stretches. So if we look at these two graphs here, or three graphs here, our base function is represented by this red function right here. Okay? And the function y equals x squared plus 3 is represented by that blue function that's just right here. And then we have this green function that represents the x squared, x minus 2, right? Just right here. So if you compare and contrast these three graphs, you'll notice that the blue function is just the base function shifted up by 3, right? So we just take, very important to realize that you keep the x's the same, you just shift the y up by 3, right? So that's what you're doing. So you go up 1, 2, 3, 1, 2, 3, right? And that'll give you your new function. If you look at the green one, it's the same thing, except now you're shifting each of these points down by 1, 2, down by 1, 2, right? So if you look at these two functions, what basically it is that when you have something like y equals f of x plus c, they're actually called vertical translations. If c is greater than 0, which is it is in the case of the blue graph, right? So if it's positive, it's going to be a shift up. So you'll notice with your blue graph, it's shifting up by 3. And if it's less than 0, it's shifted down by 3. So you'll notice that the green function is shifting down, right? So with horizontal translations, here is our base function, which is just the dark black line right there. And then we have the purple, which is going to be our function right here, right? And then we have the red, which is our function right here, right? So this one right here. So I'm just going to go highlight these. So I highlighted the red as pink because I just didn't have a red highlighter. And then for the purple, it's going to be this purpley color, right? So if we have these two functions that look like this, if we're going to compare them, in our last function they were shifting up, here they are shifting left and right. So these are horizontal translations. So when you have the x or the number that is inside the bracket, or in this case inside the denominator, or sorry, inside the radical, anything, or even like for something like this, it's x plus 2, right, inside the, like immediately beside the x, right? This is a horizontal translation. If d is greater than 0, right, when you pull it out of the function. So notice how here, technically inside this bracket, d is negative. But if I was to pull it out, just like you did in quadratics, you pull this out and it becomes d equals 2. So if inside the bracket it's negative, but when you pull it out it's positive, you actually shift it right by the number of points, by d, right? And on the flip side, so see here where it says x minus 2, so you'd think that it was actually going to become more negative. It actually does the opposite of what you think it'll do. It becomes more positive. So on the flip side, if we had x plus 3, we're actually, when we pull it out, our d value is negative 3, right? So it shifts to the left. It becomes more negative. Okay? By d points. Okay? And the reason you do this is because in the original equation, it's y equals f of x minus d plus c, right? So this minus d, when you pull it out, the sign changes. Because if you were to put in positive d into this, it would give you negative d. But if you were to put in a negative d, it would be the negative and the negative would cancel out, give you a positive, right? So you just need to be mindful of that. It's the same thing as when you were pulling k out of your horizontal function. So I think we did this one in class. So there was two ways that you could do this. I'm going to show you both ways, and then I'll go over the reciprocal function because it's a little bit more complicated. So the first way that I showed everyone in class was you just take this function and you graph the parent function. So I know the parent function here is y equals root x, right? So then I'm going to go in, I'm going to say, okay, the points that I have from my previous lesson are 0, 1, 4, and 9, right? And then 0, 2, 0, 0, 1, 2, and 3. So I'm just going to go plot that in. So I'll do it in a different color. We'll do it in the purple. Okay? So actually, I'll get rid of this for now. This is just the other graph. Okay? So let's do it in the black. So we have 0, 1, 1, 4, 2, 9, 3. So this is my parent function, y equals root x. So then I'm going to go back here and be like, what are my translations? I know that it's going to go, this is the c value because it's outside the bracket. So my c value is it's going to be -3. That means down 3. My d value is the one inside the bracket and it always changes the sign. So it's going to be d is +4. So that means it's going to be right 4. So shifted down 3 to the right 4. So let's go ahead and write that in. So I'm just going to take this point right here and shift down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. And then I can just do that for each point, right? So now I can take this point and go down 1, 2, 3, over 1, 2, 3, 4, down 3, over 4. So 1, 2, 3, 1, 2, 3, 4, and then down 3, over 1, 2, 3, 4. And that is what my new function is going to look like. Another way you could have done this is you could have gone up here and just made a second table of values, right? So you have an x, y. I know that x is going to be +4, +3, right? So then I just take 0, add 4, 4, and then I take the original. So I'm just going to do all the x's. So 0 + 4, right? 1 + 4, 4 + 4 is 8. And then 9 + 4 is 13. Now I have all of those. And then I'm just going to do the same thing for the y. So 0 + 3 is 3. 1 + 3 is going to be, or sorry, -3. My bad. It's -3 because it's going down. 0 - 3 is -3. 1 - 3 is -2. 2 - 3 is -1. And 3 - 3 is 0. So my new points are going to be 4 and 3. Wait, so 4, 3, 5, 2, 8, -1, 13, and 0. And if you look at this, that makes sense. 4, -3, 5, -2, 8, and 13. So they all add up together. Okay, so either way that you want to do this is completely acceptable. I personally like to do it by drawing the graph, drawing the coordinated pairs, because when we start adding stretches, it just makes it a little bit easier. But if you want to do it one by one, it's completely up to you how you would like to go about solving that problem. Yeah. Okay. So, if you haven't already, try this one by yourself. So pause the video here. I know we tried it in class by ourselves, but some of you really, really did like not get this. So we can try it by ourselves again. No harm, no foul, right? And then we can take it up together. Okay. So hopefully you pause the video for this. So again, this is two ways to do this as well. You could just graph the function and then translate it that way, or you can make a table of values. So I know in class, we also talked about the asymptote method. I'll go over that as well. Both of these methods work. I'm going to go over and show you the most basic method, and then we'll talk about the asymptote method. So here we have x and y, right? So the original formula, we have x -3 goes to -0.33, or -1/3. We have -2 that goes over -1/2, or 0.5. Then we have -1 and -1. -1/3 goes to -3, right? And then we have, oh, sorry, I forgot one. -1/2 goes to -2. And then we move up to, we have to skip the 0, right? Because there's no 0 in this function because x cannot equal 0. This is just for the reciprocal, like the basic. The parent function is 1 over x, right? Then we have 3, 1 over 2, which is going to give me 2, right? 1, 1, 2, 3. I'm just going to write it down. Positive 0.5, positive 0.33. And if you're like, where did Miss Sang get these numbers from? Let's go back to our original. This is where I got them from. Just the basic values of a reciprocal function. Okay, so let's go back here. Oops, let's go back here. So then what I'm going to do is I'm basically going to take these, right? And I'm going to apply my stretches. Or sorry, my shifts. So I know that I have x plus 2, so that's going to be my d value, and my d value is going to be negative 2 because it's a positive there, so it's going to be x minus 2. And then this is my c value, right? So it's going to be y plus 3. Just make sure, because this is technically its own little bracket, that's going to be inside the bracket, so that has to deal with x. So then I'm just going to do the math. I'm going to say, okay, what's negative 3 minus 2? Negative 3 minus 2 is negative 5. What's negative 2 minus 2? Negative 4. Negative 1 minus 2 is going to be negative 3. Negative 1 minus negative, or minus 1 half, or sorry, minus 2. Negative 1 half minus 2 is going to give me negative 2.5. So I'm going to do that for all my values. I'm just going to write it in instead of writing out the math. Okay, I'm just going in order. And then negative 1, 0, 1. Okay, and then on the opposite side, I'm going to take my negative 0.33 and add 3, right? Which is going to give me 2.67. And then I'm going to take my negative 0.5 plus 3, which is going to give me positive 2.5, right? I'm going to take my 2 plus 3, which is going to give me positive, or sorry, it's negative 1. Negative 1 plus 3, which is going to give me positive 2. So if I just keep going down and adding 1 to all of these, right, I'm going to end up with negative, so positive 1 here, 0, 6, 5, 4, 3.5, and 3.33. And then I'm just going to go graph these, right? So let's go graph these in here. So I'm going to graph, I won't graph the original, I'm just going to graph the final function. So I'm going to start off at negative 3. I know I'm going to go to 2.67, so it's positive 2.67, so it'll be somewhere here, right? Then I'm going to go to, sorry, that's negative 5. Negative 5, 2.67. So it's like here, right? Then I'm going to go to negative 4, and I'm going to go to 2.5, so somewhere here. I'm going to go to negative 3, and that's roughly at 2, right? Negative 2.5, like so in the middle of these two, is going to be at 1, so there's a dot right here. And then negative 2.33 is going to be at 0, so like about here. So my graph is going to look something like this. Obviously, you're going to do a better job. Maybe I'll even actually do a better job on this. Okay. We know that the reciprocal function looks like that. And we know the reciprocal function also has the other side. So then I'm going to go up and I'm going to go, okay, so now I'm going to go to negative 1.66, negative 1.66, and that's all going to go up to positive 6 right here. And then we're going to go up to, from negative 1.5 is going to go up to negative 5, so like here. I'll do a better job of drawing this closer to the 3, right? And then negative 1 is going to go to the 4. 0 is going to go to 3.5, and then 1 is going to go to 3.3, so something like that. So our graph is going to look something like this. Okay? So that's what our graph is going to look like. And if we think of the asymptotes, we have one over here at x is equal to -1 or -2, right? And then we have one here at y is equal to 3, right? And the reason that I'm drawing the asymptotes in is because I actually want you to realize that because I have one here at x is equal to 3, x is equal to -2, and one is here at x is equal to 3, right? One, that's going to tell us a little bit about the restrictions. But the other thing is what you could have done is you could have gone in and drawn in your asymptotes because your asymptotes are actually the ones that shifted and said, okay, I'm just going to pick one point on the graph. So for me personally, I would have picked like the whole number 1. So for me, I would have picked 1, 1, right? And I would have only applied the translation to the 1, 1 and the -1, -1, and then shifted it so that I could just draw my little reciprocal value. So that's one way you can do it as well. Draw in the asymptote, find one point on the graph, and draw a rough sketch of your points instead of moving everything over. Okay? For the domain and range here, the domain here is going to be D such that x is an element of all real numbers. Can think about it, it can grow in both directions infinitely. But you'll notice that this will approach this yellow line, but it'll never actually touch it, right? So then we also know that x cannot equal to 2. That's what it means to have an asymptote. We also know that because we know that this denominator, x plus 2, cannot equal 0. It should be a -2, sorry. So we know x cannot equal -2, right? So that's why that's the answer. And for range, right, it's y such that y is an element of all real numbers. And if we look at the asymptote here, it's 3. So y cannot equal 3. The other reason we know that is because if this entire thing cannot equal 0, right, this entire fraction cannot equal 3, or this entire equation cannot equal 3, because if this can't be 0, 0 plus 3 is 3. Another way to remember this is the asymptotes for a rational expression are always written as follows. They're always going to be x is equal to -d and y is equal to c. So in this situation, our asymptotes are x is equal to -2 because look, the d value here is 2. Um, and, or well, it's not negative, but you know what I mean. Like when you pull it out, it's the same. So you just change the sign, and then y is equal to c, which is 3. So that's our asymptote. If I had something like 1 over x minus 3 plus 10, right? Our asymptote would be y is equal to 10 and y is equal to, pull it out, 3. Okay? And that's it for that graph. So hopefully this kind of clarifies things. Oh, we didn't do the domain and range for this. So the domain for this one is going to be x is an element of all real numbers such that x is greater than 4, right? And the reason being, this entire thing can't equal to less than 0. It's to be greater than equal to. Can't equal to 0. So that means that in this, for this to be 0, you have to have positive 4. And then the domain, if you look at the range, right, our function is going to grow from 3 onwards. So we just need to make sure that, say, under this root sign, we have a 0, which is the minimum it can be. Our range is going to be y is an element of all real numbers such that y is greater than or equal to 3, minus 3. I'm just going to draw this so that it's a little clearer. Okay, and that's how you find the domain and range for that one. All right, I hope this helped, and I hope this makes it a little bit more clear. I will post some solutions to the rest of them as well so you can check your work.